Hey everybody, Mr. Marquardt here with you once again. Hope you all had a wonderful weekend. Got a chance to unwind a little bit, enjoy Valentine's Day, eat some chocolate, um, maybe enjoy the super cold weather if that's what you enjoy. But now it is time to jump back into algebra. Today we are doing section 4.2.4, doing more elimination with systems of equations. Before we jump into that though, a couple announcements for everybody. Last week, Thursday, we opened up homework collection number 4, and that is due, or was due, last night. So please make sure you get that submitted if you have not. And again, when you do your homework, please make sure you show all your work and all your steps, because otherwise, depending who your grading teacher is, you might not get full credit for that unless you show all your work and all your steps. Another announcement, that is 2 weeks from today, we are going to have our Chapter 4 test. This is our last week of Chapter 4, last week of new materials. Next week, Monday, we're doing our Chapter 4 closure to prepare for that test. And then 2 weeks from today, like I already mentioned, is that Chapter 4 test. So make sure you're thinking ahead, keeping up with our homework, asking questions with your grading teacher if you are stuck on stuff or not 100% understanding what's going on. So make sure that we are being responsible and proactive if we're not understanding things. And then we're going to keep kind of chipping away, and hopefully things will go well for us when we get to that Chapter 4 test in a couple weeks. But you got to let us know if you're struggling with stuff. But again, we can't help you unless you let us know that you're struggling. So again, help us help you if that is not the case. Otherwise, 2 weeks from today, Chapter 4 test, Chapter for homework collection number 4 is also due, so please make sure we get that stuff in. So I'll put the answers up for the homework very quickly from last week, Thursday, 4.2.3. Again, pause that video if you want to look at those in more detail. So that being the case, let's jump into 4.2.4 with a little warm-up question here. So let's look at these two. So if we know the equation 2x plus 3 is equal to 17, then we have 4x plus 6 is equal to 32. So what I want to think about, are these two equations both true? So think about that for a second. Are those equations both true? Remember the golden rule of algebra. So when we think about the golden rule of algebra, what that is what we do to one side, we have to do to the other when we are solving equations or just working with equations. What we do to one side, we have to do to the other. So again, if our two options here are true or false, are these two things the same equation? I think that is going to be a resounding yes. That should be true. Because all we did is we took this equation, we took everything in there, and we multiplied it by 2 to get to that bottom equation. Because 17 times 2 is 34. 2 times 3 is 6, and then last term there, 2x times 2 is going to get us to 4x, so that's how we get from this equation up on top down here. So true, those two equations are saying exactly the same thing. All right, so let's get those white packets out if we have not. Again, 4.2.4, here we go. So 4.2.4, in 4.2.3, we learned how to use the elimination method to solve systems of equations. In this method, we combined two equations in a way that made one variable disappear. So this is a really, really useful tool when we don't have an equation that looks like y equals x equals. Basically, whenever we don't have something that's all by itself, elimination is probably going to be our best bet. Not always, but probably going to be our best bet to solve that system of equations. Again, when we don't have something that is all by itself, like an x or a y or any given variable. So today we're going to get more practice using elimination to solve systems of equations while dealing with a couple different complications that might arise when we are looking at these systems. So today, again, keep the following questions in mind. How can you create one equation with only one variable? How can we create an equation with one variable? How can we eliminate one variable? And how do we know our solution is correct? Again, hopefully we know the answer to that last one for sure. We just take our solution, plug it back into both equations. If we can get the same answer on both sides, we are going to be in good shape. So let's start with 66. Which system of equations below would be the easiest to solve using elimination, using the elimination method? Once we made our decision, use that elimination method to solve our system and then check both of our answers. So first, as I look, when we want to try to solve something for elimination, we want to look for a variable that has the same number with opposite signs. So something that's going to offset or potentially could offset. So if I'm looking at A and B, looking for the same number variable with opposite signs, something that's just going to cancel if we add them together, I think we've got that right here with negative 4y and positive 4y, because if we add those together, our y's are going to cancel. So again, we know that B, we probably could use elimination, but we wouldn't really need to, because we already have this equation as y is equal to 4 minus 2x. So in this case, we could just take 4 minus 2x and then plug it into y using substitution like we talked about last week. So we're just not going to solve that one for the time being, because we want to focus on elimination just like our directions are telling us to. I would maybe recommend solving B just for a little extra practice with substitution. Check the filled in notes for that answer if you want to work through that one. But let's go back to part A, and we want to solve this system using elimination. Again, we've got that opposite pair, positive 4y, negative 4y. We're adding the like terms vertically here. So when we do that, we have 5x plus a negative 8x. We're left with minus 3x. Again, our y's cancel, so it's plus 0 y's. And then if we add 37 and negative 52, we get negative 15. So again, those y's kind of go away, so we can simplify this as minus 3x is equal to negative 15. Now we just got one step to get our x. One step to get our x, we got to divide both sides by negative 3, divide by negative 3. So those cancel, negative divided by negative makes our answer positive, so we get x is going to be equal to 5. Negative divided by negative is always a positive. So now if we want to find our y value, we can take this value for x, plug it into either one of our two equations. I'm going to plug it into the top one. So let's do that one in red at the bottom here. We get 5 times 5, because that's what x is equal to, minus 4 times y is equal to 37. All right, so 5 times 5, we get 25 minus 4y equals 37. Subtracting 25 from both sides, we get minus 4y equal to, believe that is going to be a positive 12. So now to get y by itself, just like we did up above, we got to divide both sides by negative 4, divide by negative 4, and y will be equal to negative 3. So now we have a positive over negative, our sign stays negative here. So this is negative 3. So our final answer is 5, negative 3. So we have an x and a y, always write our answers in ordered pair. So this is what we're ultimately looking for at the end of the day. So perfect. Again, if we want to check our answers, if we want to check our solution, we would take this ordered pair and then plug it into both equations. 5x minus 4y is equal to 37. Plug 5 and negative 3 in for x and y respectively. Same thing for the bottom equation. Both sides of those equations should be equal to each other. Again, we're not going to do that in the video here just for the sake of time, but if we want to check our solution, that's what we do it. So we're going to take this ordered pair and then plug it into both equations for x and y respectively. So perfect. Again, try B on your own, a little review for substitution. Check those filled in notes for the solution on that one. All right, so on to 67, we are continuing with systems. We want to first start by looking at these two equations. We got 2x plus y equals 10, 3x minus 2y is equal to 1. If we combine these equations as is, what's going to happen? Let's combine them and see. So if we add these two together, try to eliminate just with the way that they are. We've got 2x, 3x, this is going to be 5x. We got y minus 2y, so minus y is equal to 11. Uh-oh, that's not good. So what happens is that nothing cancels, right? So nothing cancels. We still have two variables in that equation. That's not going to help us solve for anything. So nothing canceled. Nothing canceled out. So we still have two variables. That's not good. So let's maybe see if we can adjust our system so we can find a way to get a variable to cancel out. So I'm going to erase that. And let's move on to part B. So is 2x plus y equals 10 the same line as 4x plus 2y is equal to 20? Sorry for the background noise, everybody. If you can hear that sloshing noise, that's my dog taking a drink out of the water bowl, making this video Saturday morning here. But anyways, are these two lines exactly the same? That is, do they have the same solutions? Let's test it and find out. So I'm going to move on over to Desmos, and let's see if we can't see what these lines look like. So I already have these things plugged in here. We got 2x plus y is equal to 10. We've got 4x plus 2y is equal to 20. So here's what that first line looks like. 2x plus y is equal to 10. So looking between these two lines, all we did was we multiplied every term by 2. So is our line going to be bigger because our line numbers are bigger now? Let's take a look. So if we activate this one, whoa, it just made that red line disappear. So as we can see on the graph, when we just look at this one, 4x plus 2y is equal to 20, that one pops up, the red line goes right over the top of it. So they are exactly the same thing. Kind of like we talked about with our warm-up. They are exactly the same because all we did was just multiply everything by 2. So they are the same line. So now let's turn the page and go to part C. So again, we know that just as long as we multiply everything in an equation by the exact same thing, it doesn't change the value of it. But let's now use the multiplied form of that. When we take 2x plus y is equal to 10, we multiply everything by 2. And now we want to use that equation to try to solve our system. So first, let's write our two equations. So our new equation that was on top before, which was the 2x plus y is equal to 10, turned into, well, let's see here. Let's just write the whole thing out. 2x plus y equals 10. And then we had 3x minus 2y is equal to 1. And again, what we did was to go from this equation to that highlighted one, we multiplied everything by 2. So we multiply everything by 2 in this top one. So every term's got to get multiplied by 2, just like we have. So what that turned into was I'm going to move this whole system over to the right here. So we had 4x plus 2y equals 20. Bottom equation still stays the same. 3x minus 2y is equal to 1. Now we have a pair of variables that are going to cancel. We got a positive 2y minus 2y. When we add those two together, those y's are going to cancel. So when we add these together now, we get 7x is equal to 21. So 7x is equal to 21. So now if we want to solve for x, we just got to divide by 7 on both sides. So when we divide by 7, x is equal to 3. So again, when we want to solve for y, all we got to do is take this x value, plug it into one of our two equations. I'm going to continue to be consistent, plug it into the top one. So when we do that, we get 4 times 3 plus 2 times y is equal to positive 20. All right, now we can just work this through, solve for y. 4 times 3 is going to be 12 plus 2y is equal to 20. Now we got to subtract 12 to get our y variable all by itself. So we get 2y is equal to 8. And then last step, divide by 2, divide by 2. So y is equal to 4. Again, write this as an ordered pair. So together we get 3, 4 for our solution. Again, if we want to check our solution, what we can do is take this ordered pair, plug it into both equations. The bottom one should be 1 on both sides. Top one should be 20 on both sides to double check that. Perfect. All right, so again, like we see in part D here, why was the top equation changed? Would a variable have been eliminated if the bottom equation was multiplied by 2 on both sides? So the top equation was changed, so again, we could get a variable when we added those together that would cancel out just like we had with positive 2 and negative 2 here. Because before we multiplied, like we can see here, and like we saw on the last page, those didn't cancel. So if we multiply the bottom one instead by 2, I'm going to rewrite our system here. We had 2x plus y is equal to 10. Again, originally it is 3x minus 2y is equal to 1. So if we multiply this bottom equation by 2 instead of the top one, I think we were going to run into a very similar problem that we had originally when we tried to combine, because if we multiply this by 2, this system turns into 2x plus y equals 10, and then 6x minus 4y is equal to, oops, not 1, but that'll be 2. So if we add these together instead here, now we get 6x, or sorry, not 6x, 8x minus 3y is equal to 12. And again, now we're in trouble because we have still two variables. Nothing canceled out, so we can't solve for either one there. So not a good start for that one. Again, we multiplied the top one by 2 because we knew that we could get those two to cancel if we multiply that top equation by 2 on the top here. All right, so let's move on. Let's go to 68. We're going to get some practice again solving these systems. Practice solving these systems. So again, we got to find something that would potentially cancel. So I'm going to let you do A and B on your own, because A is very similar to what we did last week, where we have to maybe find a way to get these 2's to cancel by if we multiply one of these equations by a common thing. Again, look back at our notes from Thursday last week if you want to have a little help for that one, or check those filled in notes. Part B, again, my recommendation tip for here would be rearrange one equation so that our variables are lined up on top of each other. So we have A's in a row, B's in a row, and then our numbers. Then we could probably combine these and simplify or eliminate a variable pretty easily. But I want to do C together because this is a little bit different. So we don't have any variables that have the same number, whether they're positive or negative. So we don't have anything that's going to cancel out because we've got 7x, 3x right here. If we add those together, we get 10x. We got 4y, negative 2y. If we add those together, we still have 2y's. So we have to figure out something to multiply one of these equations by to get our variables, or one of our variables, to cancel. And I think what I'm going to look at, again, 7 and 3, those are both positive already, so that's not going to be overly helpful. Our y's, we've got a 4y, we've got a negative 2y, so we have a positive 1 and a negative 1. So if we want to take this 2 maybe, if we can get that to look like a 4 and keep it negative, then I think we can get those y's to cancel out. So what if we multiplied everything in that bottom equation by 2? We multiply everything in this bottom equation by 2. When we do this, the top equation is going to stay the same. We got 7x plus 4y is equal to 17. On the bottom, we get now 6x. 2 times negative 2 is negative 4, still times y, is equal to negative 30. All right, so now we can eliminate because we have our opposite, or our pair of opposite values. We got a positive 4y, negative 4y. We add those together. Our y's are going to cancel. Our y's are going to cancel. So 7y plus 6y, or sorry, 7x plus 6x is 13x. Again, our y's are now going to cancel. 4y plus or minus 4y is going to be plus 0y is equal to 17 minus 30 is negative 30, or negative 13, sorry, negative 13. All right, so now we can solve for x because again our y goes away. We've got 13x equals negative 13, divide by 13, divide by 13. X is negative 1. X is negative 1. Perfect. So now we got to find y. So we can take our value for x, plug it back into one of our equations. I'm going to, again, pick the top one. So we know x is negative 1. We're going to scroll down a little bit and do it right on top of my head here. So again, that equation for that top one is 7 times x, which we know is negative 1, plus 4y is equal to 17. So 7 times -1 is -7, plus 4y is equal to 17. Next, we got to add 7 to both sides. So we get 4y is equal to 24. Now just divide by 4, and our final answer, if I slide down just a little bit more, is y is equal to 6. And then one last step, write our answer as an ordered pair. So we get x is -1, y is 6. And there is our final answer. All right, again, take a look at A and B on your own. Check that out on the filled in notes if you want to double check how you do. Otherwise, let's keep rolling with 69. So Tracy and her team were given the following system by their teacher. What we want to do is try to solve this one and see what happens. So solve it and see what happens. Let's start with that. So again, I think this is going to be a good candidate for elimination because neither equation is in y equals or x equals, or there's no variables by themselves. So let's try to figure out which variable we want to cancel here. So we got positive 10x, positive 5y, positive 4y, positive 2y. So all the variables are positive, so we got to multiply one equation by a negative number. So I think let's try to cancel our x's. Let's just try to cancel our x's. So we have 5x, 10x. I think if we multiply this bottom equation by -2, we can get our x's to cancel, because we'll have 10 or 5 times 2 is 10. We make that negative, we'll get those to cancel. So if we do that, again, we'll distribute that -2 to every single term inside here. Let's rewrite our system as 10x. Top equation stays the same. 4y is equal to -8. Bottom equation turns into -10x minus 4y is equal to -20. So now let's add it together, see what happens. We should get our 10s to cancel, or our 10x's. So again, 10x, -10x, 0x, 4y, minus 4y, that's also 0y, is equal to, now we got -28. So 0x goes away, 0y goes away. We got 0 is equal to -28. That looks kind of odd. So we know that that is definitely not possible. So not possible. So whenever we see something like this, again, when we see 0 is equal to some random number that's not 0, we've always said that our answer is no solution. No solution. But why is there no solution? So all of our variables went away. Well, why did that happen? So let's take these two equations and maybe move them around a little bit and solve them for and put them in slope-intercept forms. We're going to solve both of these for y. So again, we've got 10x plus 4y is equal to -8. And then we've got 5x plus 2y is equal to 10. So let's see what happens when we solve both of these for y. So first thing we got to do is move our 10x. So if we subtract 10x from both sides, we get 4y is equal to minus 10x minus 8. Now we're going to divide by 4 to everything over here. So we get, I'm going to carry this down here, y is equal to, now we get -10 over 4 times x. And then 8 divided by 4 is going to be -2. So if we simplify that fraction, which we can, we get y is equal to -5/2 x minus 2. All right, let's do the same thing with that blue equation. First thing we're going to do is move 5x. So let's subtract 5x from both sides. Subtract 5x from both sides. 2y is equal to -5x plus 10. Now we got to divide by 2, divide by 2, divide by 2. Our 2's cancel. So again, moving that one down here, we get y is equal to -5/2 times x plus 5. So they're not the same equation, and we can tell that because the y-intercepts are the same. But the big thing here is that number. that negative 5 halves. Again, that when we have y equals mx plus b tells us our slope. So if we have two lines with the same slope but different y-intercepts, then we have parallel lines. Oops, I can't spell. Parallel lines. Parallel lines, which, like we talked about in class last week, when we have parallel lines, they never cross. The solution for a system of equation is where those two lines cross on a graph, so that is why we get no solution. So parallel lines will never have a solution for systems of equations. All those variables will always cancel like we just had in 69. All right, folks, last one for today, 70. We want to carefully examine our system here and see if we can't figure out a way to set it up so one of our variables is going to cancel. So here we go. So we got 4x plus 3y is equal to 10, 9x minus 4y is equal to 1, and we got to figure out a common multiplier here to maybe get one of these to cancel. So if we have 3y, we go, let's see here, let's start with our x's first. So we got a positive 4x, positive 9x. I don't think there's a nice way that we can multiply 4 and 9. But if we look at these y's instead, we got one that's positive, one that's negative. Is there anything that we can multiply 3 by to get to 4? I don't think so. But what is the maybe common multiple between both of those? So if we multiply these two together, 3 times 4 would get us to 12. So maybe if we can get this top equation to be a 12y and get this bottom equation to look like minus 12y, then we can get those variables to cancel. So if we were to do that, I think we'd have to multiply the top equation by 4, and then multiply the bottom equation by 3, and then we could rewrite our equations and then solve from there. So if we do that, let's multiply the top equation by 4 first. So we get 4 times 4 is 16x. 4 times 3y is 12y. And then we are setting that equal to positive 40. On the same thing on the bottom, we multiply everything by 3. So 3 times 9 is going to get us 27. 27x minus 12y is equal to, now it's going to be positive 3. So now we can solve or combine these equations because we have our y's are going to be canceling. So if we add these together, we should get 43x plus 0y's is equal to 43. Again, y's go away, so we get 43x is equal to 43. So now 43x divided by 43, divide both sides by 43, boom, x is equal to positive 1. Now to find y, now let's go back and plug it in. So we get over here 16 times 1 plus 12y is equal to 40. 16 times 1 is 16 plus 12y is equal to 40. Subtract 16, subtract 16. 12y is equal to, now that's going to be 24. 24. So now we just got to divide both sides by 12. And then we are almost to our answer. We get y is equal to 2. And we just got to combine these two things in our ordered pair. So our answer should be 1, 2. So again, if we don't have it lined up nicely where one of these numbers, if we just multiply one equation by like 2 or 3 or negative 1 so we can get our variables to cancel, the best way that I would recommend is to multiply by the two things added together. So we have 3 and 4 together is equal to 12. Multiply the top by 3, or 4 I should say. Multiply the bottom by 3. Then we can still get to that common multiple where we know that those things are going to cancel when we add them together. Perfect. So that's all we got for today. Math notes, forms of linear equations, y equals mx plus b, slope-intercept form, standard form, ax plus by is equal to c. And we haven't really talked about that a ton other than just kind of seeing it and solving for slope-intercept form, but that is there for your reference as well. Last but not least, homework for tonight is 4.2.4. Please make sure you get a chance to look at that before you come to live class tomorrow. Otherwise, have a great rest of your Monday, everybody, and we'll see you tomorrow.